Right. Simple circuits, Ohm's law, and IV graphs. Maybe we'll get through all of this. I don't know. Let's see. Let's see how much. Okay, you got that? Yeah. Okay. Right. Who can tell me what a circuit is? It's a word you might know. Yeah.
It's a closed
Closed is a word that's in it, yeah.
thing that.
Oh, thing? No, not thing.
know
No.
to say it, but like, you know, it has a
Closed
system.
system. Yeah. Something like that, isn't it? It's a path in which electrons from a voltage flow. They flow in a closed path called an electric circuit. Now, I don't really think you need the rest, okay? Wait. I just want this much. Yeah. So, I have a picture that will explain this. Gina, do you take pictures because you can't see or because you don't have enough time?
No, it's hard to see and accent close.
Both. Okay. Do you need me to go slower?
No, it's okay.
Are you sure? No, I just realised I could. If I live streamed this to YouTube, you could all have it on your phone.
Yeah, basically. Or laptops, and you are able to pause it.
I might investigate doing this sometime. Sounds interesting.
Because sometimes I have to go back and watch the whole video again. Take some break.
Yeah. Worth investigating. Okay, you have that? Yeah. So anyways, the point where the electrons enter is called the source, and where they leave is called the return, or the ground. And they're called the return because the electrons return to it. So look, here's a picture that you need. So what happens is, where the heck is it? The electrons come out, go in this closed path, and then re-enter or return at the other side. So this is a very simple circuit, right? You got your battery, you got your load, and you got your control. Fine? No, the simple circuit, right? Of course, we can't draw beautiful pictures like this. We need a diagram. We need symbols to represent different parts. So a symbol for the light, a symbol for the switch, a symbol for the battery. So the following is the symbols that we use on this course. Now, I asked NCUK to give me a list of all the symbols because there's actually hundreds of these symbols, hundreds, and they wouldn't give me a list. They said, oh, you know, just the standard ones. I'm like, you know, so the symbols I have listed here are the ones I've seen in the last 10 years of exams, okay? So the first one is the switch. This is a switch. Now, we'll talk more about the difference between these two. This is a battery, and this one's a cell. They're different. We'll talk about that later. This is a lamp, a light. This is a voltmeter. This is an ammeter. This is a resistor. This is a variable resistor, meaning you can change its resistance. This is called an LED diode, and this is called a light-dependent resistor. Now, if you can't read them, just tell me and I'll give you the name. Switch, cell, battery, lamp, voltmeter, ammeter, resistor, variable resistor, LED diode, D-I-O-D-E, D-I-O-D-E, and light dependent resistor. And take your time.
What was the
LED diode, D-I-O-D-E. Yeah? Yeah, take your time, yeah. It's very small, isn't it? It's very small. Maybe you could even share that with people. It might be useful.
What is it? That's not light. Plus
Dependent. Yeah. Got that? So I don't know if you got the message, Dorian, but the black look is out. It's white now. That's the new fashion trend. The black is gone. White is the new thing.
The what?
I just noticed it. These guys usually wear black, except today I can see lots of white. You know.
I'm the only one that.
Dorian's
Oh,
black.
Dorian
Yeah.
is also
Yes.
I'm just stable.
It's
I'm
a
more
co-
like
constant,
bluish.
constant, yeah. Alright, you got that? Yep. Okay. Do you have that, Diego?
Oh, you can continue.
Yeah.
Yeah.
Okay, so a couple of vocabulary now. Series and parallel. I don't know, you think you know these words? Diego, do you know this? Harry, do you know these words? Series and parallel? You should know parallel from maths class. What does parallel mean?
So you have one. after
Yeah,
the
yeah,
other.
yeah, yeah. So, this is what I mean when I say series, and this is what I mean when I say parallel. And this is series. So you should draw this diagram. Oh, you should also know series from maths class, shouldn't you?
Yeah.
What lesson does that come up in? Sequence and series, isn't it?
Yeah.
Isn't it? Sequence and series? Sequence and series? You've done? No, you've definitely done it. Geometric and arithmetic. Oh, yeah. Yeah, yeah.
Seems fine.
Got that? Yeah? Diego? Continue?
Yes.
Yeah? English time! So, I told you earlier I'll explain the difference between battery and cell. So here we go. One battery is not called one battery. We call it a cell. Okay? Is okay? Two or more cells is called a battery.
A battery is composed of cells.
Exactly, yeah. So, you can say this. Well, actually, you can tell me. I have a 3 volt cell. Can I say this? Right, that's right. Okay. I have 2 connected 3 volt cells, therefore I have 1 battery. Right or wrong? Right. I have 3 connected 3 volt cells, therefore I have 1 battery. Right? I have 2 connected batteries. No. No. Yeah, you only have 1 battery. I have a 3 volt cell, therefore I have 1 battery. It's wrong. So it's simple guidelines, but the reason for this, there's also another problem. Now, I don't know if you guys know this, but I don't want this to fall out. When I was ordering this battery, it came in 3 different versions: a 4 cell, a 6 cell, or a 9 cell. So you might be complaining, why can I call this a battery when I only have 1? Well, actually, I don't. It looks like 1, but inside this one there's 4 cells. You know? So obviously 6 cells will last longer than a 4 cell, and 9 cells is the most, I think. I think this one's just a 4 cell. It's the cheapest one. So you just have to be careful. I know it's a bit annoying, but like, you know, these things here, I know we call them batteries. Yeah, but really, this one should be called a cell, because I think inside one of these is only 1 cell, I think.
Some of them have those small.
Maybe, I don't know. I wonder if it says on it, if it's 1 cell. I thought these guys were only 1 cell.
I know of the small ones, like I know the normal, you know, AA.
Yeah.
Some of them, if you open them, are made of those kind of chip things, you know, like
Circle discs?
circle thing, yeah.
Okay. Anyways, you get the idea, yeah? Okay. So I hope you're clear on the difference between battery and cell. Anyways, there's 2 cells in this. Yeah? Okay. Is it okay? Your phone battery is a battery because it probably has many cells in it. I don't know how many. Okay. So we have some rules. If I go back to the picture earlier. So we're going to look at series first. Sorry, where the heck's my pen? Come on. There we go. So we have a series which is like this. And there's maybe 1 resistor, and there's another resistor. Okay. So, first rule is current is constant. What I mean is if there's a current here of I, which I measure on my ammeter, and then I measure it again here, and I measure it again here, okay? It's always going to be the same. Doesn't change. So first rule is current is constant. First rule. You can write that down. Yeah, it's okay. So what was for lunch today?
Shawarma.
Nice. You too?
Chicken, but with the shawarma instead of chicken.
Chicken what? Like,
Gojun.
oh, the chicken goujons, yeah. Lunch? You had one as well? Good stuff. I bet Gina made her lunch. You had your own lunch today? Yeah. See, you're healthy. Yeah? What you have for lunch? Nice. And Harry? Your lunch? It's good and unhealthy.
I think you heard that thing. 1 shawarma a day keeps the doctor away.
No, you just made that up.
A well-known thing.
You tell that to Joan now, see what she thinks. She likes shawarmas too.
Really?
Yeah, you tell it to her. You tell her you heard that and see what she says. Right, the next rule. So you can write this as a formula if you want. I1 equals I2. Resistance is additive. So what I mean is, if you have one resistor here and one resistor here, okay, that's the same as this. One big resistor equals, and this one is R1 plus R2. Okay? So resistance is additive. Make sense? Yeah? Now, I wonder, before I do the next one, does anybody know what happens with voltage? Is it like current, that it's constant? Or is it like resistance, and that it's additive? What do you think? You think it's like resistance? Yeah. So if you have one voltage here, V1, and one voltage here, V2, but if you measure the whole voltage, you'll discover the answer you get will be the same as V1 plus V2. So in other words, they're usually not equal unless they're the same, and they add up. Okay? Okay? Yeah? Now the next one I think would be good to demonstrate. So the next one is you have your battery, which is your two cells. So here's my two cells. So here they are in series, okay? What's the rule for these? If this one has a voltage V1 and this one has a voltage V2, then if you put the plus with the minus, the voltage adds. So you get V equals V1 plus V2. But if you put them the wrong way, if you put the plus with the plus, then the voltage minus subtracts. So for example, if this was 4 volts and this is 1 volt, you actually only end up with 3. But if you put them the right way around, then you get 5. So you probably have noticed this whenever you put batteries into something, the positive always goes on the negative when they connect, because you want your voltage to add. So, does anyone know the voltage of these cells? I put them in already. Yeah, do you know what it is? It's 1.5. So if I have 2 of them, then I have 3. Got that? Yeah? So obviously, the next rules we're going to do are the parallel rules. Parallel, huh? You ready, Diego?
Yep.
Yep. So, the first one is if they're in parallel. What happens with the current? So suppose you have a current here of I1 and a current here of I2, then the current at the end, when you look at the total, will be I1 plus I2. So current is different and adds. Okay? Yeah? Got Got that? Gina? Makes sense, yeah? Does anybody know what the story is with the voltage? So for example, if I measure here voltage V1, and I measure here voltage V2, and then I measure the whole voltage around the whole system, does anyone know what happens here?
There's a multiplier or something?
Not multiply?
No, it's like
It's the same, yeah. The same as what? Which one? Yeah, V1 equals V2 equals the V. So the I skipped the resistance, sorry. Before I do the voltage, does anyone know how the resistance combines? I think some of you do. It's 1 over R equals 1 over R1 plus 1 over R2. So resistance obeys this formula and voltage obeys, it's the same. If they're in parallel, the voltage must be the same. Where did we see something like this before? The spring. And believe it or not, we're not finished with this. We'll see a formula like this again. It's kind of a common thing in physics, this reciprocal. Okay. Does anybody know what happens with the batteries if you put the batteries in parallel?
They add up,
Maybe. Huh? What do you...
isn't it? If you have like 6 and 6,
In parallel?
you get 12. Oh no, like
In parallel. Like, for example, one here and one here.
oh no, they have the same. Yeah, they
Like-
have the same. Yeah.
No, not necessarily. We'll study this one later. It can get a bit complicated. Yeah. Okay, do you have those rules? Yeah? Question? You sure? Looks like you have a question. No? It's okay? Okay. I believe you. Right. Let's have a look at an example. So I'll draw this again to make it a little bit clearer. You've got 4 resistors. One here. One here. One here. One here. And you've got your 5, there's 5 volts in the middle here. So this is 5 volts. And this is 1 ohm, 2 ohms, 3 ohms, and 4 ohms. And 4 ohms. Okay? And my question is, find the current. Okay, let's do this one together now. Can I get blue? Right, so the current goes from positive to negative. So what happens is the current starts off here, and then what happens when it gets to here? It splits 2 ways, doesn't it? Then it goes along, 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 and then when it gets back to here, it rejoins. So this is the path it takes, yeah? Okay. Now, let's do this one. So, a little trick first. Can you imagine where did I put my hands? Here's me. Whoop. Whoop. The heck? What I'm going to do, can you all see? Can you imagine I take the wire in the middle, I lift it up and just bring it closer to me. Now, is that still the same circuit? Yes, because all I've done is just move the wire. I haven't disconnected anything. Do you understand? So what I'm doing is this now. I still have my 4 resistors. Okay? But now I've pulled this over here. Do you like I just pulled it over. Nothing has changed, right? Then what I do is I take these 4 and I just kind of straighten them out a bit. So now it looks like this wire here goes like this. And then this guy here, do you see it splits in two? I'll just put one up here and one down here. And then it connects into another two. Can you see that I haven't changed anything? But I've just made it a little bit neater to look at. Can you all visualize the changing? Yeah? So what number is this one? This one is 1, 2, and then hang on. Now, which way? Which is which?
4. So 4 and 3.
Like this, yeah. Yeah. Okay? So I should combine these now. Do you see what's I'm making like a little flow chart here. So on the top I have how much? 3. And then on the bottom? 7. Is that still okay? Goodness. And this is still 5 volts. And now what do? Now I combine these two. So now my picture looks just like this. Okay, let's combine. Oh, come on. Let's combine the top two. 1 over r equals 1 over 3 plus 1 over 7. So 1 over r equals 10 over 21. So the R here is 2.1. This resistance here is 2.1. Now, I know the R and I know the V, so can I get the I? Yeah. I use the triangle. So the I is V over R. So what is that? 0 point something? Thank you. What is it? 2.28 amps. Sorry, 2.3. No, 2.38. 2.38. Gotcha. Like this. Now what we have to do is we have to go backwards. Let's see. So, well, actually, okay. I want now the current here and I want the current here. Do I know the voltage here and here? Yeah, what is it? It's 5. Now why is it 5? Because the total is 5, and remember this and the total are always the same. It was this rule when it's in parallel, rule 3. Okay? So how can I get the currents here and here? Again, using VIR, it'll be 5 over 3 and 5 over 7. 5 over 3 and 5 over 7. So that's equal to
5 over 3 is 1.6666.
okay.
5 over 7 is 0.7142.
714. Now notice, if I add these two together, I will get 2.38. Yeah? If I add these two together, I will get 2.38 roughly. Because,
2.380.
yeah, these two combine to give me the total current which I have in this picture. Yeah? Are we okay with that? Okay. So if I go back to the very beginning, maybe you guys can tell me. Let's start here. Okay, so the first one, here, can you see? What current is that? This one here. That is the 1.67. Okay, and here?
0.7.
No, that's
no,
1.6.
Yeah,
that's the same. That's 1.67. Sorry, and here?
That's the 0.7.
Yeah, here and here is 0.714. 714 amps. But then here in the middle, that is 2.38 when they combine. It's 2.38. Sorry, the picture's very messy now. I'll do colours. Here to here is 1.67 amps, and then here to here was 0.714 amps, and then they combine here and to make 2.38 amps. So this is the picture at the end of the current. 3 different currents in this circuit. Is this okay? It's a little hard, I know, but do you want to write something down, or do you need to write something down here?
I'll look it up after.
Yeah, it's gotten a bit messy, hasn't it? I think you seem to get it. Yeah? Okay, well, we continue with another example, maybe. How are we doing for time? Oh yeah, we're okay. Right. Actually, maybe I want to give you one before continuing. Yeah, I think I'll make one up. Because I would want you to practice. Let's see. How difficult do we want this? Okay. Oh yeah, okay. No, I think I got something in first. Yeah, now we're talking. Okay, we'll make this 10 volts. And what I'm going to do is I'm going to put an ammeter here. And you know what? I'll make your life a little easier. I'll make all these resistors the same. So I'll say each resistor is 2 ohms. 2 ohms. And my question is, find the current I on this one. Okay? I like it. Yeah, give it a try. Now, it won't be as bad as you think. Give it a try. The trick is knowing which one to start with. So, where do we begin here in simplifying?
The small ones, and then
Well, let me put it like this. A, B, C. Which part should I start with?
B,
Yeah, good, B. And then what do I do?
and then you do A to B. And then
Yeah, and then
C.
to C. Yeah. Alright, let's see, Mr. Smart Guy. Give it a try. Oh yeah, you guys never sent me your essay. You said you'd do it after class. It's funny because at lunchtime I was just talking to Colin about how forgetful you are, and I said, no, they're not that bad. And then I realised, oh yeah, I did ask them to send the essay twice and they didn't. Now, after class.
Oh, I don't forget.
Please don't.
We still have to do the introduction, right?
No, just the body.
No, yeah, but like.
Oh, we will. That'll be this week.
Okay.
Right, have we got this? You think you got it, Dorian? Maybe? I just made up the numbers, so it could be anything. You got the current? Yeah. Is it a lot of resistance in total? Yeah. Did you get it, Lynn? Harry? Yeah. Gina? Okay, let's have a look. That should be enough time. So, what's wrong? Okay. Well, look, we'll add these two together first, okay? So that's 1 over 2 plus 1 over 2, which equals 1. Doesn't it? So, that's a 1, and that's a 2. So up here is 3. And this is the same, so this is 3. So 1 over 3 plus 1 over 3 equals 1 over r. So 1 over r equals 2 over 3. So r is 1.5. So all of this is 1.5 plus this. So total 3.5. So if you use your triangle, the I is 10 over 3.5, which is 20 over 7, which is a number, I'm sure, 2.84. Oh, that's not too bad, I suppose, for guessing. Right, 2.86 amps. Is that okay? Yeah, did you get that? Did you get that? You didn't get this because you said it was very small.
No, yeah, because I missed that one.
Yeah. Lynn?
Why is it 1 over 2 at the beginning?
The rule. We're using this rule because it's in parallel. Yeah? Yeah? Is that okay? Continue? Right, okay, let me think now. Oh, there isn't time to continue with the next topic. I'll just give you one more circuit. I'll have to continue this next time. What circuit will I give you? How many resistors do you want? Pick a number between 10 and 100.
99.
21.
21.
Let's. Oh, what was the last one? The last one was in parallel, wasn't it? Okay, let me think. Let me think. What would be interesting?
Lamps also count as
Huh?
resistors, right?
Say again?
Lamps.
Lamps count. I was thinking of doing something with lamps. Let's say we have something like traffic lights or something, I don't know. Or it doesn't matter. Christmas lights, whatever. So we have some Christmas lights lined up. And we'll make each, they all have to be the same, of course, so we'll make them each, 3 ohms. Oh, I know what we'll do. We'll keep this nice and simple. We'll put 2 AA batteries. So that's 1.5 volts and 1.5 volts. Okay? And I need to make this a bit more interesting. What could I do next?
Remote control.
A switch is hardly that interesting, is it? There's a switch.
Yeah, I need every multiple switch and pass switch actually because it's
How could I make this more interesting? It's already quite boring. Fine. Give me, what would I like? Oh, I know what I like. I know what I want. I want V1, V2, and V3. No, I'm changing it. Now I know. I'm going to make it 1, 2, 3. Now it's interesting. All right. Give me the 3 voltages. So my tip, I give you a little tip. Perhaps the first thing you should do is find this current here. That's my tip. Okay, we got an answer? Yeah, good job, Harry. So the first thing you want to do is get this current, I think, using VIR. I equals V over R. Now, if we look at the total, what's the V? Yeah, because these add. And the R? 6. So it's 0.5 amps. Now, I'm very sorry, I forgot to say this earlier with the cell. The big line represents plus and the small one represents minus. I didn't say that earlier. Okay, so we know the current is 0.5.
Yeah.
But that means we know the current here, here, and here. Why?
because
It's the same. It's the constants in series. So by using this again, we can say V1 equals I times R1. V2 equals I times R2. And V3 equals I times R3. And the 3 voltages we get will be 0.5 volts, 1 volt, and 1.5 volt. By the way, if you add those 3 voltages together, what do you get? 3 volts, which you should. Because the voltage consumed by the lamps must equal the voltage provided by the battery. Because this is conservation of energy. You know, remember, what is 1 volt? 1 volt is, do you remember, 1 joule per coulomb. So if this guy is providing 3 joules per coulomb, then these guys must be using those 3 joules per coulomb in making light. Yeah? Then does that make sense? Okay. So look, there's no homework in this. What I need you and want you to do is get the questions from earlier finished tonight. There's only 7 or 8 of them. Also, I hope you have your materials questions mostly finished. Yes? No? You know, the questions from last week. There was a few exercises that were very big. How are they? Are they nearly finished? Half finished? Huh? Young's modulus, there was lots, wasn't there?
Yeah, 20.
Well, if you got at least 10 of them done, that's good.
Yeah.
How much did you get done in Young's Modulus? Okay, that's good. Well, anyways, when's our next physics class? Tomorrow? Tomorrow? Tomorrow morning? 11 o'clock or something, maybe? Right, we'll continue this tomorrow. So, who's seen column now?
Me?
And? Just the two of you?
No, sorry.
Yeah, just the two of you?
Three.
Oh, the three of you.